All right, we're going to go on to our last section for the final review for Module 7. We're going to focus on some questions that are a bit more higher yield for your exam here. So if the correlation between two variables is positive, what relationship do the variables have as they change? As one variable increases, so does the value of the second variable. So if we want to think about positive, basically when we're talking about correlations, we're plotting two variables on an x-y axis and looking at their relationship. So if we have a positive correlation, we're going to end up having a positive slope in our graph, okay? So as one variable increases, so as we move like to the right, we see that the value of the second increases as well, or it goes up, okay? And this is denoted as a positive correlation. Okay, now this question didn't ask that too, but just to go over it a little bit as well, a negative correlation is going to be the opposite. Whereas one variable increases, the other variable decreases. Okay, and it's going to be related to a negative slope on your graph here. Okay, so as you're going from left to right, let's say we're going on that right axis there, left to right, to get back to the line, we're actually going to have to decrease. So as we're increasing in one way, we're decreasing in another, okay? So that means we're going to have a negative correlation here. Okay. For positive correlation, we have positive, positive. Okay. What is interpolation and extrapolation when it comes to regression models to predict? Okay, so interpolation is talking about it being within the domain of the data, and interpolation is what you want to do when you're predicting values in a regression model, whereas extrapolation is outside of the data that was made of. So this can cause issues because you don't really know the trend of your data outside of your extreme values for your domain, okay? So let's say we collected data and it went from 1 through 5 in the domain, right? Domain is correlated with your x values, and then your range is correlated with your y values. Here, values for interpolation, actually this changes up a little bit. Let's do, what was my trend here? I don't know, let's just put 70 there. Okay, so our domain here is defined as 1 to 8. Okay, well, 1, 2, 3, 4, and 8. Okay. So, but the values that I want to stress here specifically are the extreme values, our smallest number and our largest number. For interpolation, it would be looking at our regression line, which is usually in an mx plus b form. And we can use any values in between 1 and 8 and make an assumption from it. So values that we can do here would include 5, 6, and 7 if we were going to go through the whole number mark. We could also do decimals as well in between 1 and 8. Okay, extrapolation would be outside of this domain. So like the number 9, like the number 10 would be outside of this range because it's greater than 8. Similarly, if we wanted to if we wanted to find the value for 0, that would be outside of this range as well because our minimum value is 1. Okay, and these are the ones that are dangerous because they're not included in our initial data set range, and interpolation is okay. So really no, at least the caveat related to extrapolation here. Okay, so we are using a least square regressions model to predict y values from x values. If the x values we collect are in a range of 50 to 70, that's like our domain. Which of the following values represent interpolation and which represent extrapolation? Okay, so our values are from 50 to 75. And if we're looking at the value 95, this is outside of 50 to 75, which means that we're working with extrapolation here. Okay. Be sure that make sure that you're comfortable with identifying when values are extrapolated or interpolated. Okay. Number 40. For children, the metabolic rate was found to follow a least square regression model of y hat, just to make it a little bit clearer, I'm going to write that in as we would usually see it, is equivalent to 0.813x plus 0.14, which is the weight of a child in kilograms, and y follows the metabolic rate. Approximate the metabolic rate for children that weigh the following. Okay, so x was defined as the weight, and y is the metabolic rate. So if we're predicting the metabolic rate, that means that we don't know our y values in this case. So to do these problems, I'm going to rewrite the equation first, and then I'm going to plug in the values that are given to us. So if we're working with 20 kilograms, I'm going to plug in 20 kilograms where I see the input for weight, which is our x value, And I'm going to calculate this out. So 0.813 times 20 is going to give you 16.26. You can add that value to 0.14. And that'll give you an approximate metabolic rate of 16.4. Okay, just to do another example of this here, we have 10 kilograms. So y hat is equivalent to 0.813x plus 0.14. Again, we're given the weight and we want to predict the metabolic rate, which is our metabolic rate is our y hat and our weight is x. So I'm going to plug x in where I see the weight and do the calculation. So based off of PEMDAS, we're going to do the multiplication first, which is going to give us 8.13, and we're going to add 0.14 to it. This gives us y hat of 8.27, or an estimated metabolic rate of 8.27. Okay, so these, you plug in the x value and you find the y value. Okay, what are the null and alternative hypotheses when running a one-way ANOVA test? So recall that when you're doing an ANOVA test, you're working with multiple means, more than 2 here. So you're working with like 3+. And here, the null hypothesis is always going to be that the means are equal to each other. And the alternative hypothesis is that at least one mean is different from the rest. So it doesn't mean that all of them have to be different here. These two statements are ones that that's like sort of like a memorization thing. So make sure that you are familiar with those for the exam, especially the null hypothesis. Okay. And I think we got two more left. Okay. So number 42, what are the assumptions required to run a one-way ANOVA test? Okay, so we talked about this one a little bit, that we need to have at least 3 groups or samples being tested. It's important that they're independent from each other, so that you're not including data points in one group into another group, and that all of them have like their own data sets basically. And here you want to approximately have the same variance. So if you remember, variance is related to like standard deviation, or like variance is basically a type of value that looks at the spread of the data. So we want to make sure that even though they are independent samples, that they have like a similar kind of spread to the data, or a similar kind of look to it. So there isn't like one group that has like a lot of outliers versus one group where all the data is like very close to each other. So the nature of them should be similar. We also do not have to, so a big assumption that we do not need, or basically a statement that's not an assumption, is having approximately the same mean. Okay, because this is what we're testing. So if you're assuming it, then you're going to sort of be biased towards your null hypothesis, and then like what's the point of running the test? Okay, so the big part here is that they have a similar variance, and that they do not have to have approximately the same mean. So just emphasize that, not an assumption. Okay. Last but not least, on the exam you might be given a table similar to this, where you have to find your output and answer a couple of questions based off of it. So here they want us to determine from this table what the p-value is. So we go to where we see p-value, and underneath it gives us that p-value. So our p-value here is going to be 0.1311. And then we want to run this test at an alpha of 0.05 and make a conclusion based off of it. Okay? So here we have 0.05 and 0.1311. You have our alpha and our p-value here. So here we see that our p-value is greater than our alpha. This means that we're going to fail to reject the null hypothesis. Okay. So remember that fail to reject based off of p-values and alphas is super, super important for this exam. You're going to run into a decent amount of those questions. Okay. And that concludes our review. Best of luck on your studies, and please send me any emails if you have any questions on this content leading up to it.